All right, we're going to talk about exponent rules. And first, I'm going to define an exponent with an integral exponent. So if we have a to the b, and b is a positive integer, and a can be any real number, then a to the b is a multiplied together b times. So, for example, a squared is a times a cubed would be a times a times a. And so when we're talking about integral exponents, the word is integral. It's G. That means that it is an integer, or it's whole. So integral exponents are integral exponents are exponents that are integers. Okay, so if we look at the first example of rules, if we have x cubed times x to the fifth, well, the x cubed part means that we have x multiplied together 3 times. X to the fifth means we have x multiplied together 5 times. And so all together, we have x multiplied together 3 times and then multiplied together 5 times. And that would be for a total of 8 x's multiplied together. So whenever we have the bases are the same and they are multiplied then we add their exponents. So that would be a to the n plus m. Another rule would be if we have something multiplied together raised to an exponent. So that would be a times b times a times b, and we would do this again n times. So we would have n of these AB pairs multiplied together. Now because of the real numbers, we can reorder these. So I can have a times a, and I can get all the a's multiplied together. So that would be n of those. And then I can put all the b's together. And there would also be n b's. So I end up with a to the n times b to the n. So if I have something in parentheses raised to an exponent, and it has to be multiplied, it doesn't work for addition. But if it's multiply, then I can take each factor raised to the n power. So, and then the last rule we're going to look at here is if you have something raised to an exponent raised to an exponent. So let's look at a specific example for this. So let's have x squared to the fifth. So I get x squared multiplied together 5 times. That's what the fifth to the fifth exponent means. So I have it multiplied together 5 times. And then, well, from the other a few slides ago, I'm going to add up all these exponents since the basis is the same. So 2 added together 5 times, that's repeated addition, which is multiplication. And so I would get 10 x to the 10th. So whenever we have an exponent raised to an exponent, we multiply. So when we have the same bases, we add the exponents. And when we have an exponent raised to an exponent, we multiply. So let's look at a few examples. So let's say we have x squared y to the third times x to the third y. So we'll have it like that. So I can reorder these, and I get x to the 2 plus 3 and y to the 3 plus 1, and I end up with x to the 5th, y to the 4th. I could have something like xy to the 5th times x squared y to the 9th. Okay, so from the previous slides, we're going to start off with, we get x to the 5th, y to the 5th, and then we still have x squared, y to the 9th. So I can reorder the terms. And so this is going to give me x to the 5 plus 2 times y to the 5 plus 9. And so that is x to the 7th, y to the 14th. And that would be my final answer. Okay, one more example. I have x squared y to the 5th raised to the 7th power times y squared. Okay, so what's going on here is I'm going to get x squared to the 7th, y to the 5th to the 7th, y squared. Now I'm going to multiply these, so I get x to the 14, and y to the, hang on, my computer flipped out. There's something in the way. Here we go. Okay. 5 times 7 is 35, and then y squared. Okay, so there's no other x terms, so I get x to the 14th. But here I have the bases are the same, so I'm going to add 35 plus 2, which is 37. And that would be my final answer. And that's all I have to show here.